or companies have built terminal coding agents. They all do roughly the same thing on the surface. You type a prompt, the AI reads your code, edits your files, runs your tests. But underneath, they have made radically different engineering decisions. And those decisions reveal completely different philosophies about what an AI coding tool should be. This video is a technical deep dive into OpenCode, Claude Code, Codex, and Gemini CLI. No drama, no hype, just architecture. Let's start with the most fundamental question you can ask about any software project. What language is it written in? Because here, every team made a different choice, and those choices tell you everything. Codex is written in Rust, 96% Rust to be specific. It is a massive workspace of 48 crates, compiled with Bazel and Cargo. The terminal interface uses Ratatouille, a Rust UI framework, and here is the thing that makes Codex architecturally unique. The core library enforces at compile time that no module can write directly to standard out or standard error. All user-visible output must flow through the TUI abstraction layer. That is not a convention. That is the Rust compiler refusing to build the binary if you violate it. Claude Code is written in TypeScript. Running on Bun, this might seem like a pedestrian choice until you realize what they did with the user interface. Claude Code renders its terminal interface using React Inc. That means React components, the same framework you use to build websites, are rendering as ANSI escape codes in your terminal. Every piece of the interface is a React component with props and state reconciled by React's diffing algorithm, but outputting terminal characters instead of DOM nodes. Gemini CLI is also TypeScript, also using React Inc. for its terminal rendering. But it runs on Node 20, not Bun, and it has a much more traditional architecture. A monorepo with two primary packages, one called CLI for the front end, one called Core for the back end, clean separation, standard tooling, S-build for bundling. And then there is OpenCode, which might have the most interesting technical story of all. It was originally written in Go using the Bubble T TUI framework, but after a dispute over the project's direction, the team forked and completely rewrote it in TypeScript on Bun. And here is where it gets wild. They did not use React Inc. or Bubble T or Ratatouille or any existing terminal framework. They built their own from scratch. It is called OpenTUI, and the rendering core is written in Zig. A Zig native binary handles layout computation, dirty rectangle optimization at 60 frames per second, and terminal rendering. On top of that Zig core sits a Solid.js reconciler, so the developers write declarative reactive components in TypeScript, and the Zig layer handles the actual pixels. No other coding agent has done anything like this. So right away you can see the philosophical spectrum. Codex says performance and safety guarantees matter above all else, so we use Rust. Claude Code and Gemini CLI say developer velocity matters, so we use TypeScript with React. And OpenCode says we want developer velocity, entirely new framework with a Zig core. Now let's talk about how these tools actually edit your code, because this is where they spend most of their time, and the approaches differ in subtle but important ways. All four tools use some variant of exact string replacement for file editing. You give it the old text and the new text, and it swaps one for the other. But the details vary. Claude Code's edit tool requires that you have read the file first. This is not a suggestion in the documentation. It is a hard requirement enforced by the tool system. If you try to edit a file you have not read, the tool call fails. This prevents the model from making blind edits based on assumptions about file contents. OpenCode takes this further with what it calls file freshness tracking. When the agent reads a file, OpenCode records the timestamp. When the agent later tries to edit that file, OpenCode checks whether the file has been modified since it was last read. If it has, maybe because a formatter ran or the user changed it in their editor, the edit is rejected. The model has to reread the file and try again with current contents. This prevents a whole class of bugs where the AI's mental model of the file has drifted from reality. Codex does something entirely different. Instead of exact string replacement, it uses a custom patch format that is not standard unified diff. It has its own syntax with markers like begin patch, update file, and end patch. And crucially, it includes fuzzy matching. The patch system normalizes Unicode punctuation variants. So if the AI generates an end dash where a hyphen should be, the patch still applies correctly. It also applies patches in reverse order to prevent position shifts when multiple changes affect the same file. Gemini CLI keeps things relatively simple with a write file tool for full file overwrites and a separate edit tool for targeted changes. No freshness tracking, no custom patch format. Straightforward and reliable. Let's talk about terminal execution, because this is where security gets serious. All four tools let the AI run shell commands on your machine. The question is, what happens between the AI deciding to run a command and the command actually executing? Codex has the most aggressive sandboxing of any of these tools. On macOS, it uses Seatbelt, Apple's kernel-level sandbox framework, to enforce declarative security policies. File read and write permissions are explicitly allowed listed by path. Network access is restricted by default. On Linux, it layers 3 separate mechanisms. Bubble wrap for file system isolation using user namespaces. Seccomp for syscall filtering, literally restricting which system calls the process can invoke. And Landlock, a Linux security module for fine-grained file access control. On top of all that, Codex applies hardening to itself. Core dumps are disabled. Debugger attachment is blocked. Library injection environment variables like LD preload are stripped. This is genuine defense in depth at the operating system level. But Codex goes even further with something called the Guardian system. This is a separate AI subagent that automatically reviews approval requests before they reach the user. The Guardian receives a compact transcript of the conversation, assesses the risk on a 0 to 100 scale, and auto-approves anything below 80. If the Guardian times out, fails, or returns malformed output, the request is automatically denied. Spell closed? The Guardian itself runs read-only with an approval policy of never, so it cannot escalate or request further permissions. And its prompt explicitly instructs it to treat the conversation transcript as untrusted evidence, not as instructions to follow. So even if the main model has been prompt injected, the Guardian is designed to catch the suspicious behavior. Claude Code takes a different approach to security. Instead of kernel-level sandboxing as the primary mechanism, it relies on a layered permission system implemented in the system prompt and application logic. Tools are classified into 3 tiers. Read-only operations like file reads and grep need no approval. File modifications need approval, but the approval expires at the end of the session. Bash commands need approval, but the approval can be granted permanently for a specific command pattern in a specific project. The permission rules support glob patterns. You can write rules like allow bash npm run star or deny read ./.end. And critically, deny rules at any level cannot be overridden. The evaluation order is deny first, then ask, then allow, with first match winning. Claude Code does have OS-level sandboxing for bash commands. FileCell sandboxing devising Silebix are complement to the permission system, not the primary defense. The philosophy seems to be that intelligent prompt engineering, telling the model what not to do with extremely emphatic language, is the first line of defense, and the sandbox is the backstop. OpenCode does something clever with its bash security that none of the others do. Before executing any shell command, it loads a tree sitter bash wasm grammar and parses the command into an abstract syntax tree. It then walks the AST, extracts arguments to file system operations like cd, rm, cp, and mv, resolves the paths, and checks whether any of them fall. outside the project directory. This is more sophisticated than simple regex pattern matching because it understands the structure of the shell command. A command like rm-rf/important would be caught even if it were nested inside a complex pipeline. Gemini CLI takes yet another approach. It uses a re-execution model for sandboxing. Instead of wrapping individual commands, the initial CLI process acts as a launcher, spawning a new child process running the same CLI binary inside an isolated environment, and then the original process exits. It supports 4 different sandbox backends: macOS seatbelt with 6 built-in security profiles, Docker or Podman containers with custom base images, gvisor for user space kernel isolation on Linux, and even LXC containers for full system environments. When YOLO mode is enabled, which auto-approves all tool calls, the sandbox is automatically activated too. This is an elegant design. Want full automation? Fine, but then you are getting full isolation. Now let's talk about context management, which is arguably the most important engineering challenge in building a coding agent. These models have finite context windows and real code bases are enormous. How you manage what the model sees determines how well it can reason about your code. Claude Code is architecturally optimized for what Anthropic calls prefix caching. The system prompt, tool descriptions, and project instructions are placed at the very beginning of every API call. Because this prefix is identical across turns, the key value cache from previous calls can be reused. Anthropic reports a 92% prefix cache reuse rate, which means that on most turns, the vast majority of the input is served from cache at 1/10 the cost. When the context window fills up around 95% capacity, Claude Code automatically summarizes the conversation history. The prefix survives because it is reread from disk, and sub-agents have their own isolated context windows, so verbose output from things like test suites never pollutes the main conversation. OpenCode uses a dual mechanism. The first line of defense is tool output pruning, which scans backward through tool calls and replaces old outputs with short placeholders while protecting the most recent 40,000 tokens. This is lighter weight than full summarization. If pruning is not enough, a dedicated hidden compaction agent generates a structured summary focusing on what was done, what is in progress, and what the user's constraints are. This triggers at 75% of the model's context window. Codex has a similar compaction system. When approaching context limits, it generates a summarization prompt from the full conversation history. The summary replaces historical messages while preserving recent user messages up to a 20,000 token budget, processed in reverse chronological order. If even single-item prompts exceed limits, the system iteratively removes the oldest items and retries. Gemini CLI triggers context compression at roughly 60% capacity earlier than the others. But it has a structural advantage. Its default context window is 1 million tokens. That is roughly 50,000 lines of code. So in practice, compression kicks in less often because there is simply more room. It also supports just-in-time context discovery, where project instruction files are automatically loaded when the agent accesses files in new directories, adding relevant context only when it is actually needed. Let's talk about project-level instructions, because every tool has its own convention for this, and they are all slightly different. Claude Code uses cld.md files. These are loaded from multiple locations in a specific precedence order. Managed policy files at the system level, project files in the repository root, and user files in your home directory. Claude Code walks up the directory tree loading these files at each level, and it also supports lazy loading from subdirectories when files there are accessed. There is an import syntax using the @ sign, so you can modularly compose instructions from multiple files. And there is a separate .claude/rules directory for path-specific rules that only activate when relevant files are touched. All of this survives context compaction because the files are reread from disk. OpenCode uses OpenCode.json for configuration and supports project documentation files as well. Its configuration system merges from 7 different sources in a specific precedence order from remote well-known endpoints down to managed system-level configs. This is more complex than the others, but gives administrators fine-grained control. Codex uses agents.md as its project context file. It walks upward from the current directory to find the project root, then collects every gents.md from the root down to the current directory, concatenating them in order. It also supports an override file, agents.override.md, which takes precedence. Gemini CLI uses gemini.md, but interestingly, the file name is configurable. You can set it to accept multiple conventions, including agents.md or context.md, so you can share the same file across tools. Now let's talk about provider lock-in, because this is one of the starkest philosophical divides among these tools. OpenCode is the most radically open. It supports over 75 LLM providers through the Versal AI SDK, which provides a unified streaming interface regardless of which model you are talking to. You can use Anthropic, OpenAI, Google, Mistral, Grok, Together, Fireworks, Llama, LM Studio, or any OpenAI compatible endpoint. You can even use different models for different tasks, planning with one model and executing with another. The metadata for model capabilities, things like context window sizes, and tool calling support comes from a database called models.dev maintained by the OpenCode team. Claude Code is tightly coupled to Anthropic's models. You can run it through direct Anthropic API, Amazon Bedrock, or Google Vertex AI, but it is always talking to a Claude model. There is no way to point it at GPT or Gemini. This is a deliberate trade-off. By optimizing for a single model family, Claude Code can deeply exploit model-specific features like prompt caching, extended thinking with thinking budget keywords, and the exact behavioral characteristics of Claude's tool calling. Codex is primarily an OpenAI tool optimized for GPT models like GPT-5.4. But it does support local models through Llama with an OS flag, so you can run it offline with open weight models. The API communication uses OpenAI's responses API over WebSocket, with features like sticky routing and connection pre-warming that are specific to OpenAI's infrastructure. Gemini CLI is locked to Google's Gemini models. It uses Google's Gen AI TypeScript SDK directly. There is no native support for other providers, though you can route through a light LM proxy as a workaround. So the spectrum here is clear. OpenCode says the model is a commodity. Use whatever you want. Claude Code and Codex say we are the best model, so we will optimize everything for our own stack. And Gemini CLI says the same thing but sweetens the deal with a generous free tier of 1,000 requests per day. Let's go deeper into subagent architectures, because this is where the tools diverge in fascinating ways. Claude Code has a well-defined hierarchy of subagent types. The Explore agent uses Haiku, Anthropic's fast cheat model, for quick code-based searches. The Plan agent inherits the parent model but is restricted to read-only tools. The General Purpose agent gets all tools and handles complex multi-step operations. You can also define custom subagents as markdown files with YAML front matter in a .claude/agents directory. Subagents cannot spawn other subagents. Preventing infinite nesting, they can run in the foreground or background, support persistent memory with configurable scope, and can even be given isolated Git work trees so they work on separate copies of the repository. OpenCode's task tool creates an entirely new session for each subagent with restricted tool access. This is architecturally clean. The subagent gets its own database back session, its own message history, and its own context window. The parent only sees the summary that comes back. OpenCode also has 3 hidden system agents that run automatically: a compaction agent for summarizing context, a title agent for generating session names, and a summary agent for session descriptions. Codex has a collaboration system with protocol-level events for spawning, interacting with, waiting on, and closing collaborative agents. The protocol defines collab agent spawn, collab agent interaction, collab waiting, and collab close events, suggesting a peer-to-peer child hierarchy. Gemini CLI supports subagents defined in Gemini.md files with their own system instructions, model selection, and tool configurations. A notable security detail is that subagents run in YOLO mode by default, meaning they auto-approve all tool calls without individual user confirmation. This is a trade-off favoring convenience over per-action oversight. Let's talk about hooks, because this is where these tools start to feel like programmable platforms rather than simple command line utilities. Claude Code has 17 hook events spanning the entire lifecycle of a session, from session start to session end, from before a tool executes to after it fails, from subagent lifecycle events to configuration changes. The most powerful hook is pre-tool use, which can return a permission decision of allow or deny, effectively creating a programmable permission system. Hooks can be shell commands receiving JSON on standard in HTTP endpoints, prompts sent to a Claude model for evaluation, or even full subagents. Gemini CLI has a similarly comprehensive hook system. It fires events before and after model calls, before and after tool execution, and at various session lifecycle points. Hooks communicate through JSON on standard in and standard out with exit code-driven flow control. Exit code 2 blocks the operation, similar to Claude Code's approach. OpenCode and Codex also support extensibility, but through different mechanisms. OpenCode has a plugin system with shell environment hooks that augment the environment before spawning processes. Codex has its skills system and rule files for controlling command execution. Let me talk about one more dimension that is often overlooked: how these tools handle LLSP integration, meaning how they connect to language servers that provide type checking, linting, and other real-time code intelligence. OpenCode is the clear leader here. It has over 30 pre-configured language server definitions built in, covering TypeScript, Go, Rust, Python, Java, Swift, Haskell, Elixir, Zig, and many more. Servers are lazily spawned only when files with matching extensions are accessed. After every file edit, OpenCode notifies the relevant language server, waits up to 3 seconds for diagnostics with a 150 millisecond to bounce, and feeds any errors or warnings back to the model. The model gets real-time type checking feedback. It also exposes LSP query capabilities directly to agents, including hover, go-to definition, find references, and workspace symbol search. On top of that, 28 built-in formatters, things like Prettier, GoFMD, RustMT, and Rough, run automatically after edits. Claude Code does not have built-in LSP integration in the same way. It can connect to language servers through MCP, the Model Context Protocol, but it does not ship with pre-configured servers or automatic diagnostics feedback loops. Codex and Gemini CLI similarly lack deep LSP integration out of the box. Gemini CLI's grep tool can optionally use ripgrep for faster search, but that is search, not language intelligence. This is a meaningful difference. When OpenCode's model edits a TypeScript file and introduces a type error, it finds out immediately and can fix it in the same turn. The other tools would need the user to run the type checker manually or wait for tests to fail. Let's zoom out and talk about the business models, because they inform the technical decisions. Gemini CLI is free. 1,000 requests per day with a Google account, access to the full Gemini model family, and the project is Apache 2.0 licensed. This is Google's developer adoption strategy, getting developers comfortable with Gemini models by making the tools free and open. OpenCode offers a zero-friction onboarding experience through what it calls Zen hosted pre-tested models that work out of the box with no sign-up or credit card. This is their revenue source, but you can bring your own API keys for any of the 75+ supported providers. Claude Code requires an Anthropic API key or access through Bedrock or Vertex. There is no free tier for direct usage. Codex requires an OpenAI API key or can use local models through Alama. There is a research preview model available for Pro subscribers. Now let me bring this all together. These 4 tools represent 4 distinct philosophies about what an AI coding agent should be. Codex is the fortress. It is written in Rust for maximum performance and safety. It has kernel-level sandboxing on every operating system. It has an AI guardian reviewing every dangerous action. It prohibits direct standard output access at compile time. Every architectural decision prioritizes security and correctness, even at the cost of complexity. If you are working in an environment where a single wrong command could be catastrophic, Codex Defense in-depth approach is unmatched. Claude Code is the prompt engineer. Its architecture is built around the insight that a sufficiently detailed system prompt can control model behavior more effectively than complex application logic. The system prompt contains emphatic behavioral constraints, uses words like never and critical and important in all caps. The permission system, the safety rails, the tool usage preferences, they are all implemented primarily through prompt engineering with application-level enforcement as the backstop. And by coupling tightly to Claude models, it can exploit features like prefix caching for a 92% cache hit rate, dramatically reducing costs. OpenCode is the platform. It treats the model as a commodity and builds everything else to be modular and extensible. 75+ providers, a custom rendering engine built from scratch, a client-server architecture where the same running process serves terminal, desktop, web, and VS Code clients simultaneously. Tree sitter-based security analysis, 30+ language server integrations with automatic diagnostics feedback. It is the most architecturally ambitious of the 4, and the one that most aggressively bets on the future being multi-model. Gemini CLI is the ecosystem play. It pairs a solid, well-engineered tool with the most generous free tier in the market. Extensions, skills, subagents, hooks, and MCP support create a plugin-rich platform. The re-execution sandbox model is elegant. The 1 million token context window means less context management overhead. And by being fully open source under Apache 2.0, it invites the community to extend it in ways Google cannot anticipate. None of these tools is objectively the best. They are optimized for different values. Security versus openness. Model specialization versus model agnosticism. Prompt engineering versus application logic. Platform ambition versus focused simplicity. The right choice depends on what you value and what constraints you are working within. If you are in a regulated environment where security is paramount, Codex's Rust-based, kernel-sandboxed, Guardian-reviewed architecture is hard to argue with. If you want the tightest possible integration with a single model family and you are willing to pay for it, Claude Code's prompt engineered approach delivers remarkable coherence. If you want maximum flexibility to mix and match models with deep language intelligence, OpenCode's platform approach gives you the most options. And if you want to get started for free with a 1 million token context window and a growing extension ecosystem, Gemini CLI is the obvious entry point. The fascinating thing about this moment in software development is that all 4 of these tools exist. All 4 are actively maintained, and all 4 are making fundamentally different bets about the future. The tools you choose shape the code you write, and the AI coding agent you choose shapes how you think about the relationship between human intent and machine execution. Choose deliberately.